Hello, it is Monday, March 23rd, 2020, and we're all still in exile, but we're here together to learn about Section 9.5, the Quadratic Formula. Now, I am just recording this at home right now. Hopefully you can hear and see everything on the screen okay. It's not going to be super high production values or quality, but we're going to do the best we can with what we've got so that we can keep on learning, keep on moving forward, keep on mastering all things quadratic and making sure that we are ready for high school next year. So we're going to start off today by taking a little walk down memory lane. Remember this challenge that I gave you last time I saw you? It was, how can we take a standard form quadratic formula with a's and b's and c's in it and get x by itself using completing the square? So some of you tried that. Some of you sent me your attempts. Some of you did it. Good job. Before I answer that, I want to just remind you about how to use completing the square in general. So here's an example with numbers in it. If I have 4x squared plus 6x minus 12 equals 0, and I'm going to try to complete the square to solve that. Here is what I'm going to need to do first. First, I'm going to get rid of that minus 12 so that I just have 4x squared plus 6x with a blank space there so that I can complete the perfect square trinomial. Now remember, when we're completing a perfect square trinomial, we want to unsquare this, and then whatever is in this blank should get unsquared, then combined with this. Oh, wait a second. You know what? Scratch all that. I don't like the 4 here. Aren't these easier if we don't have a coefficient in front of the x squared? Yeah. Let's divide everything by 4. And let's do it this way. If we do that, then what we're going to have is x squared plus 6/4 x equals 12 divided by 4 is 3. Now I'm going to rewrite that with 3/2 x because 6/4 is 3/2. And then now, now let's try this. Unsquare. Unsquare. We don't know what that is yet, but we'll find out. That was my attempt at a question mark. Then whatever that is times that, you're going to smush them together and then double it to get that. So if we undouble that, what's the undouble of 3/2 x? It'd be 3/4 x. And that means, what's this question mark right here going to be? It must be 3/4. And that means, what must this be here? The square of that, which is 9/16. Lovely. Okay, if I add 9/16 here, I've got to add 9/16 here. And then my next step will be, I've got x and 3/4. It's that squared, because now I have completed the square, equals, what's this going to be? 3 in terms of 16ths is 48/16 plus 9/16 is 57/16. That's going to be fun. On our next step, when we square root both sides, I'm going to basically have x plus 3/4 equals plus or minus the square root of 57/16. But notice I can't unsquare the top, but I can unsquare the bottom, can't I? Yeah. Then when I take away 3/4 from both sides, my solution after all of this is going to be negative 3/4 plus or minus square root of 57/4, which eventually can be combined because they have a common denominator, and I get negative 3 plus or minus the square root of 57 over 4. And of course, you could put that in your calculator, get a decimal approximation of that if you would like to. But that's how we do the completing the square method. And this was like the most complicated, kind of painful version of doing that we might have to do. Now, what if I'm going to try to do that whole entire process, but I'm now going to do that whole entire process just with A's, B's, and C's. What was my first step over here? Get rid of this. So what's my first step going to be here? Get rid of this. That's going to give me ax squared plus bx equals negative c. Then, notice what I did next was I divided everything by that a value. So I'm going to divide this whole thing by a, and that's going to give me just x squared plus this divided by a equals this divided by a. Pretty weird. Now I'm going to do my unsquare. I don't know what this is yet, but I know that when I smush them together and then double it, I get b over a x. So that's the doubled version. The undoubled version would be half of that. So what's half of b over a? B over 2a. So that's the lovely thing that goes here. That means that this right here is b over 2a, which means that this up here is the square of that, b squared over 4a squared. And we're going to add that to both sides. Having fun yet? This is exciting times. All right, what that gives me is x plus b over 2a squared equals, whoa, what do I got over here? Can I combine these? Yeah, if I get a common denominator, 4a squared, this one is a b squared. What would have to happen here? I'd have to multiply by 4a on the bottom. So I'd have to multiply by 4a on the top. So look at the lovely thing that I have over here. Negative 4ac plus b squared over 4a squared. Then I'm going to square root both sides. So when I unsquare this, I get x plus b over 2a equals the square root of this. Now, can't forget the plus or minus, okay? The top cannot be square rooted, but I am going to rewrite the top as b squared minus 4ac because that just feels better to me to have the positive and then minus that part. And then I can unsquare the bottom. What's the square root of 4a squared? 2a. That might be helpful when I do this step to get x by itself. You following along okay so far? Fun stuff. Finally, I have the answer. And it is x all by itself equals negative b. And look, there's a common denominator here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And I did it. I got x by itself with no x's on the right, just an x here and all that fun stuff over there. So if you were wondering how to do that, that's how to do that. What's the point of me telling you this? I thought that was just extra credit. I thought it was just a challenge. I thought we didn't need to know how to do that. Well, you don't necessarily need so much to know how to get from here to here, but you need to know this. This right here is going to become a revelation to you, an absolute gift to you. This is going to become for you a way to solve any quadratic equation. You don't have to complete the square. You don't have to graph it. You don't have to factor or use magic numbers. You can use this formula, which we call the quadratic formula, to solve any quadratic equation by just taking whatever the a and the b and the c values are and plugging them into this formula to get your solution. So, would you take a look with me real quick at the problem that we just did right here and watch how much easier it's going to be to do that problem using the quadratic formula. What's the quadratic formula? The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. All I have to do is, for negative b, I'm going to plug in my b value. For b squared minus 4ac, I'm going to plug in my b value. Minus 4 times a times c. Don't forget the negative. And all of that over what? 2 times a. What was a? 4, so 2 times 4. Now, do you think just plugging all that in and working out the math is a lot easier than that? I think so. And watch. We can finish this problem by just doing the math. Probably best to do this part first. 36 minus 4 times 4 times... Oh, minus minus. So it's going to be 36 plus something. So 4 times 4 is 16. 16 times 12... Uh-oh, I didn't bring a calculator with me. 16 times 12... There's my calculator. Is 192. Okay, this is going to be interesting. 36 plus 192, on the bottom we get an 8. And I can do 228, negative 6 plus or minus the square root of 228 over 8. Now wait a second. That's not what we got before. When we did this before, we got negative 3 plus or minus 57, square root of 57 over 4. What's the difference? Why did we not get the same exact thing? Which one is right? Which one is wrong? Well, this is just a simplified version of this. How can this simplify into that? Well, you know that the 6 and the 8 can reduce to 3 and the 4, but can you reduce the 228 by just dividing it in half? No, because 57 isn't half of 228. How did the 228 turn into a 57? It has to do with something like this. 228 divided by 4 is 57. So really, the square root of 228 is the square root of 4 times the square root of 57. And what's the square root of 4? 2. So if we divide this by 2, divide this by 2, we divide everything by 2, that's how we're going to get negative 3. This goes away, and you get the 57. The 8 turns into a 4, and that is our solution using the quadratic formula. Easier, I think, and I'll just tell you, this problem right here is one of the hard kinds. So it can be a lot easier to use the quadratic formula to solve a simpler problem. Here's an example. What if I was solving x squared minus 12x equals negative 20. And I want to use The quadratic formula. What's the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you have it memorized yet? Probably not, but you will over time have this memorized because you're going to use it over and over to solve several problems, and you'll get to know it pretty well. So, what's the a value? What's the b value? What's the c value? A is 1. B is negative 12. C isn't negative 20 because isn't this supposed to be over here? So it would become a positive 20. You got to be careful with that. Now I'm just going to plug those values in. What's negative b? Negative 12 would be 12 plus or minus b squared. Negative 12 squared is 144, positive, because when you square it, it becomes positive, minus 4 times a. What's a? 1. Times c. What's c? 20. All of that over 2 times a. What's a? 1. And now I can keep on going. 4 times 1 times 20, that's 80. What's 144 minus 80? That's 64. And we know the square root of 64. That's 8. So what are my solutions to this equation? 12 plus 8 over 2. And 12 minus 8 over 2, which are 20 over 2, which is 10. And 4 over 2, which is 2. And so the quadratic formula doesn't always produce weird, irrational, gross answers. Sometimes it produces really nice, clean answers as well. By the way, real quick, why did that one come out nice? Because if you rewrote this, you could have just done this with magic numbers. 10 and 2. Oh, wait a second. It's negative 10 plus negative 2. Negative 10 times negative 2. This is, yeah, you remember how to do this, right? And so that's why we get those same two answers. I think this is easier. Magic numbers is probably the easiest way of solving quadratic equations. However, does magic numbers always work? Not always. What's the benefit of this? It might not be easier, but it always works. Every time, 100%. It never fails. If you can remember that quadratic formula, all you have to do is plug in some numbers, simplify, 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 and get your solutions. All right. How about one or two more examples? I'm not trying to make this video ridiculously long, so I apologize if I'm taking my time, but I just want you to know this really well. You can pause this and take a break if you need to at any point. 10x squared minus 5x equals 25. What's my A, my B, and my C? Negative B, that's negative negative 5, so that's 5 plus or minus. What's B squared? 25. What's A? 10. What's C? C would be negative 25, right? And then over 2A, A was 10. So the bottom is going to be 20. The top is going to be 5 plus or minus. Oh boy, what's going to happen here? Well, that's going to become addition. So 40 times 25 is... Oh my goodness. Let's just do it. 40 times 25 is 1,000 plus 25. Can you square root that? No. So we can use a calculator if we want to get an estimate of this. Or can we just leave it the way it is? Yeah, we could leave it the way it is, but we could simplify this one as well. What do I kind of want to divide this by? 5, right? Can I factor this so that it's a 25, which I then can divide a 5 out? Let's find out. 1025 divided by 25. So 5 divided by 5 is 1. This divided by the square root of 25 is 41. And dividing by the square root of 25 is the same as dividing by 5. And what's 20 divided by 5? 4. That would be the best solution to this problem. Although, would I accept that one? Maybe on a nice day if I'm feeling good. All right, finally, I'm going to give you one more example. Again, feel free to pause if you need to give your brain a minute to catch up, but we're going to do one more. By the way, you've got all this whole week to digest this and practice it. This is the only thing you need to learn this week. So if you want to just stop right here and watch the rest of the video tomorrow and give your brain a chance to slowly digest this over time, that's totally fine. All right. If I was completing the square, I'd have to do this whole messy thing where I divide everything by 2, I move the 18 over to unsquare, blah, blah, blah. But I'm going to use, the quadratic formula. What is the quadratic formula? There's a lot of ways you could memorize this. People make songs of it. The way I like to think of it is negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. Didn't think you'd get music today, did you? But like it or hate it, there it was. What's negative b? Negative 8 plus or minus b squared, that's 64, minus 4 times a, which is negative 2, times c, which is negative 18, all over 2a, which is 2 times negative 2. This is going to be our solution, and all we have to do now is try to simplify it. So don't worry about that part yet. Let's worry about the part inside the radical. That's the thing that we kind of got to reconcile first. Now I've got a minus and a minus, which will become a plus, but then it's still going to be a minus, right? So on this one, it's going to be 64 minus whatever 4 times 2 times 18 is. Anybody see a problem coming? 4 times 2 times 18. Doesn't really matter what this is and what this is if this comes out to a negative. We've got a problem, don't we? You can't unsquare a negative. That's not really too much of a problem, because all we know now is that this equation has no solution or no solutions. It's kind of nice when this number inside of the radical turns out negative, because then you can just stop. You're done. You realize there's no solutions, and that's it. So I want to talk just for one more second before we close this video out about that number inside the radical. It has a name. That b squared minus 4ac part of the quadratic formula has a specific name. It's called the discriminant. The discriminant. The discriminant is b squared minus 4ac. It's called the discriminant because it allows you to discriminate between what kinds of solutions you're going to have when you do your solution method problem solving scheme. So I'm going to just show you a quick page from your math book. This is page 586 in your textbooks, by the way. I hope you have your textbooks with you. You're supposed to have a home copy of your textbooks. It's got a little bit of a glare on it, but you can turn to page 586 yourself if you need to look at this. Can I maybe that's a little bit easier to see. The discriminant. Okay, we've got all these different ways to solve quadratic equations. That's good to review. But now that we know the quadratic formula, you might want to just use the quadratic formula every time, and you can. You're allowed to now. So remember, sometimes a parabola doesn't have any roots, zeros, solutions, x-intercepts. When the discriminant is negative, like the case that we just saw, there's no solution. Sometimes that parabola just barely touches the x-axis, and you only have one solution. That's going to happen when your discriminant comes out to 0 because the plus or minus part goes away, and it's just b squared, or just negative b over 2a, and that's your one solution. And then most quadratic formulas are going to have two solutions because most of the time that b squared minus 4ac is going to come out positive, and then you have to actually solve it. So that page might be helpful for you to review. Ultimately, what you're going to need to review and remember a lot over and over and over the course of this next week is the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. If you can remember that, you've got a way to solve any quadratic equation, no matter what its a's and b's and c's are, whether it's a perfect square or not, whether you got magic numbers or not, whether its graph is pretty or ugly, you can solve anything. Your assignment, and you've got all week to do this, is for section 9.5. I just want you to go to page 587, and I would like you to do numbers 11 through 24 and 53 to 56. I think that's 18 problems, and you've got a whole week to do it, so take your time, pace yourself if you want to. I will, at some point later in the week, post the answers to these so that you can see if you were doing it correctly. Thanks for hanging with me. This video is a little bit longer than I had hoped or intended. Future videos will be shorter for your benefit. You guys are awesome. I miss you all. That's it. Have a good week.